Welcome to station number 2, square roots versus cube roots. So essentially in this station we are going to be looking at those ways that we can break down areas or volumes, or using side lengths we can create areas or volumes. So let's do just that. Let's figure out first, what is a square root? A square root, quite literally, is a comparison of square area to side length. So looking at this, we have a square with side lengths indicated. So we know the area of a square is essentially base times height, or we could also say side times side, or side squared. And based on that, if we know what the side lengths are, we could figure out the area, or if we know the area, we should be able to figure out the side length, because the area is the square root of the side length. Notice that this computer program is making me put a little 2 above there. That's indicating that it's a square root, much like when we have just an x by itself in an equation. We don't necessarily need to write that it's 1x. In all reality, I could just write this symbol, and that would indicate to you that we have a square root. So please don't be thrown off by the little 2 that's there. That can be there, but if it's not, it still is indicating a square root. If there is a different number than a 2 there, if it's say a 3 or a 4, if it's a 3, it's a cubed root. There's a 4 there, it's a 4th root. If there was a 10 there, it would be a 10th root. In this case, we are only going to be looking at square and cubed roots, so please don't worry about those. So looking at a square root, this is what we are looking at. We're looking at literally a square area versus the side lengths. So, do I want to go there? Yes, we can go there. So when we are solving square roots, we need to ask ourselves essentially, what is being described in the equation? If we know what's being described in the equation, we can usually figure out, do I need to square something, or do I need to square root something? So we need to decide in these situations which side of the equation is the area and which side of the equation is describing the side length. And then after that, we should be able to answer, how do I get x by itself? So if I look at this particular situation, I have x is equal to the square root of 16. Square root of 16 is telling me that 16 is the area, and we are figuring out the side length with the x. So if I were to take the square root of 16, which we all know is equal to 4, the x is indicating the side length, so I can say 4 units. In this other situation, we have the square root of x is equal to 16. So in this case, this 16 in this case is the side length, whereas this x right here is the area, because again we are taking the square root of that area. So in other words, to undo it, we have to square both of those sides, so we would get x is equal to 256. Oh, I can't get my 256 units squared. So essentially we're finding that x is quite literally the area and 16 is the side length. It's hard though, because whenever we see 16, we're not necessarily thinking we need to square it and get an area out of it and getting a really big number. And sometimes when we look at 16, we're not really anticipating, if we're square rooting it, we're not necessarily anticipating that we're going to get a much smaller number. Either way, always ask yourself, what is being asked by this? How do I need to figure out the area or the side length? Next, let's look at cube roots. What is a cube root? A cube root compares the volume of a cube to its side length. So here we have a cube, which I tried to draw, it didn't work out very well. And the volume is quite literally base times height times width. Or if we were thinking about a cube, all of those things are the same. So it's a side times a side times a side, or side cubed. The side length is essentially base height or width, or it's essentially the cube root of a volume, or the cube root of the base times width, or times width times height, or the cubed root of side cubed. So looking at just that, if we're looking at the cubed root of side cubed, this cube root of 3 would cancel out with that power of 3, so all we would end up getting is an s. So in other words, that cubed root is undoing the cubing. That's a lot of cubes. Sorry. That's just how it goes. So there's the cubed root that's undoing the cubing. Essentially, it's opposite operations, just like multiplication is the opposite of division, or addition is the opposite of subtraction, black is the opposite of white. Just understand those are the opposites. So if you see a cubing happen, you might have to cube root it to be able to undo that. So let's look at some examples. Here we go, not knowing where I need to go. So here we go. We need to solve a couple of cube roots, and again we need to ask ourselves the same thing as we were asking with the square roots. Which side of the equation is the volume? Which side of the equation is the side length? Then you need to ask yourself, how do I get x by itself? So you're going to have to probably do the opposite. So looking at this first equation, we have x is equal to the cube root of 8. 8 is our volume. And because we're taking the cube root of that, we know x is the side length. So we are figuring out that if I undo that, or if I have this 8 and I take the cube root of it, I'm going to get just the side length of it. It's like showing that I have this cube, and this cube is a volume of 8, and I just want one of the sides, which is going to be 2. So my x is equal to 2 units. This other one, we have the cube root of x is equal to 8. We are looking at x this time, it's the volume, and this 8 is our side length. So in order to undo what's happening to our x, we need to cube both sides. So the cube root is undone by that cubing, and all we have left is x. 8 cubed is 8 times 8 times 8. And so we end up getting the answer of, my pen just keeps disappearing, 512 units cubed. So then we're seeing that the volume is a much bigger number. Let's look at a couple of equations to practice. We need to solve this x squared is equal to 20 and x cubed is equal to 90. So in both of these situations, we are talking side is our x, and this other side of the equation is our area or our volume. So we know that the x is our side because it is being squared or it is being cubed, meaning if I were to take the side length and say this was x and this was x and the inside is 20, essentially the square root of 20 would get me my x. So that's exactly what I need to do. I need to take the square root of x and the square root of 20. The square roots undo the squaring on the x, so I just simply get an x because they undo each other. And now we have the square root of 20. Now we could just be done with it there, but I'm trying to get you guys to break down some of these square roots. So looking at the number 20, I want you to ask yourselves, are there any squared numbers within 20 that I could take out of the square root? And I could say, well, I have 4 times 5. So I can say x is equal to the square root of 4 times 5, which is also equal to the square root of 4 times the square root of 5, which means x is equal to 2 times the square root of 5. And that would be my final answer. So that side length is 2 times the square root of 5, which is square root of 5 is about 2.2-ish, so 2 times the square root of 5, so it's 4.4 units in length. Doesn't really mean much to us, but this is our exact answer, and we can say units. Should probably put that in our box. So let's look at volume. Again, we're looking at a situation where we have a cubic area. This cubic area is 90 units. And I just want to find out the side length of this area. So I can find any one of those x's, which means I need to cube root the 90. So let's do just that. If I say the cube root of x is equal to the cube root of x to the third is equal to the cube root of 90, I get simply an x left over, and I get the cube root of 90. Now I need to see if I can break down this 90 into some triplets. I need to find the same number multiplied by itself. So I can say I have 2 times 45. I then have 45, which is equal to 9 times 5. And lastly, 3 times 3 gets me 9. No triplets, so x is equal to the cube root of 90 is my simplest form of that particular number. And I truly don't know what it is. That's okay. I like that the cube root of 90 is my final answer, better than any number that it is. If I think about the cube root of 90 and where it lies on a number line, I can essentially say that 4 times 4 times 4, so the cube root of 64 is 4, and the cube root of 125 is 5, so it's somewhere in between 4 and 5. Great, fabulous. Probably about 4.5. So, practice this stuff with your current station. See how you do. If you have any questions, make sure you ask, and I will see you later. Thanks so much for watching.